Welcome to my first video of the Five New Technologies podcast. Um, for all of my technologies, I'm going to be using tools that are mainly made for physics students and that they can utilize in the classroom. First, these being a simulation-based one, the physics classroom provides easy to use simulations, activities, quizzes, and labs for students to practice self-discovery and application of new concepts. The objective that I might choose for a physics student is to explore how force, mass, and coefficient of friction affect the velocity of an object and derive new relationships based on these variables. My target audience is going to be a high school physics class. The standard for an educator that I apply to this is to design authentic learning activities that align with content area standards and use digital tools and resources to maximize active and deep learning. And the standard for a teacher is to inspire a culture of innovation and collaboration that allows the time and space to explore and experiment with digital tools. The website's pretty easy to navigate. For the purposes of what my experiment would be, they would click on physics simulations from the web page, then click on Newton's Laws Interactives. The specific simulation they're going to choose is the force one, and they would click Launch Interactive to be able to then interact with the user interface. We're going to go explore that right now. So, go to beginning. Okay, so this is what the beginning of the page looks like. We got simulations, video tutorials, concept builders, we got calculators, test prep, quizzes and question banks. They have an online laboratory with 150 labs. There's lots of things that can be done on here, but we're going to click on physics simulations. We're going to pick Newton's Laws Interactives. There we go. And then we're going to click the force one. So once we launch interactive, so as I said, it's a pretty easy to use software. Students can change the the mass of an object that's being pushed, how much force is being applied to it, and then they can see, oh, okay, so it's moving pretty fast. However, when we up the friction and push it, now it starts moving really slow. They can see how fast the object moves when you decrease. And now they found out it won't move. But they can play around and determine how the object will move based on the mass, the force, and the surface friction. And they can develop their own relationships between mass and velocity, force and velocity, and surface friction and velocity based on how these results pan out. There's other interactions on here, other tutorials and other simulations, but that's just one of them that my students could use.